let's take a look at how we would prove this identity. So we have sine to the power of 6x plus cos to the power of 6x is equal to 1 minus 3 sine squared x cos squared x. Okay, so first off, we're going to start by working only with the left-hand side. Okay, and so in order to prove this identity, you need to know the sum of cubes formula, that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And in this case, we're going to let a represent sine squared x and b will represent cos squared x. And so now we're going to change the sine to the power of 6x to sine squared x cubed. And we're going to do the same thing with cos to the power of 6x. We're going to change it to cos squared x cubed. Okay? And now we're going to factor this using the sum of cubes formula. Okay, and we're going to get sine squared x plus cos squared x in this bracket, and in the second bracket we're going to get sine to the power of 4x minus sine squared x times cos squared x plus cos to the power of 4x. Okay, and so now recall that sine squared x plus cos squared x is equal to 1 according to the Pythagorean identity. So we're going to replace this with 1. Okay, so this bracket's going to be equal to 1. And so now we're just going to be left with this expression. Next, we're going to decompose the middle term. Okay, so the middle term is going to be decomposed to 2 sine squared x times cos squared x minus 3 sine squared x times cos squared x. Okay, and now we're going to move cos to the power of 4x beside these two terms. And so this term is now going to become the last term. We're going to group these four terms together. And so now you have to recall the binomial expansion, that a plus b squared is equal to a squared plus 2ab plus b squared. And in this case, a will represent sine squared x and b will represent cos squared x. So this expression here is going to equal to sine squared x plus cos squared x squared. Okay, so if we expand this, we're going to go back to this expression, okay, according to the binomial expansion formula. And so now, once again, the sine squared x plus cos squared x can be replaced with replaced by 1, and so we're going to get 1 squared minus 3 sine squared x cos squared x, which will just give us 1 minus 3 sine squared x cos squared x. So we have shown that the left hand side is equal to the right hand side. Okay, so we have proven this identity. Thank you for watching.